All right, so now we have worked through our different exponent rules. We're going to talk about a couple more situations in which exponent rules apply, but different types of exponents than the usual ones that we've been looking at. So we're going to be looking at square roots and other types of roots, like cube roots and quad roots and so forth, but mostly square roots. And then we're going to relate them to fractional exponents. So the next couple class periods, we're going to be talking about fractional exponents and how they're related to different types of roots. So our essential question is, how are roots and fractional exponents related? So first off, I want you to be thinking about what each one of these numbers down below raised to a first or second or third all the way up to a sixth power would be. Now, if you happen to have your iPad calculator or a calculator close by, that would be maybe helpful today. But we're just going to walk through each one of these. So 2 to the first power means just 2 and not multiplied by anything else. 2 to the second power, of course, means 2 times itself, so 2 twice being multiplied, which hopefully we remember is 4. And then 2 to the third power is 2 times itself 3 times. 2 times 2 is 4, times 2 is 8, and so on and so forth. So we're looking here, 2 to the fourth power then is 16, 2 to the fifth power is 32, 2 to the sixth power is 64. Any of you guys who watch the either men's or women's NCAA basketball tournaments in March know that there's typically 64 teams in the main brackets, although they've added a few, and it requires 6 games to get to the championship game, and win the championship game would be the 6th game. So that's because 2 teams play each other in each round. So notice that we have half of the teams in the second round, and then the Sweet 16, and then Elite 8, and then the Final 4, and then the championship game, all factors of 2. So 3 to the first power then, we have just 3. 3 to the second power, 3 squared, would be 3 times itself, which is 9. 3 to the third power, 3 times 3 times 3 is 27. 3 to the fourth power, if we multiply by 3 again, we get 81. If we multiply by 3 again, we get 243. And if we multiply by 3 a sixth time, we get 729. Maybe some of those numbers are familiar to you. Powers of 3. Powers of 4 are also a common power that we see sometimes pop up. So 4 to the first power, of course, is 4. 4 times itself, 4 times 4 is 16. Times 4 again is 64. Times 4 again is 256. Times 4 is 1056. And times 4 again is 4096. And our last set of powers would be powers of 5. 5 to the first. 5 squared is 25. Times 5, we've used this one a few times in some of our problems, is 125. Times 5 again is 625. Times 5 again, 3,125. And times 5 again is 15,625. Okay, so we may be referencing this chart now as we think about how these are related to something called a square root. You guys have seen square roots before, I think. But square root is this little symbol right here. So the square root of 25 is 5. In fact, let's put it in red since I used that up here. Notice the 25 here. Because 5 squared is 25, so the square root of 25 is kind of working backwards to be what number times itself is 25. 5 times itself is 25. So 5 is the square root of 25. It's kind of the opposite. It's kind of like undoing a square. A square root, it's like adding and subtracting undo each other when we're solving equations. They're inverses of each other. Multiplying and dividing are opposites of each other. When we solve equations, we do the opposite. Well, squaring and square roots are opposites of each other. So this means to find the square root of 25. And that means to find the number that you square, we talked about that just a second ago, to get 25. So 5 times itself is 25. So this means to find the number that you multiply by itself to get 25. So as we said, 5 times 5, since 5 times 5 is 25, that means that 5 is the square root of 25. Okay, so let's look back at our chart and think about what are some of the square roots that we see up here. So what is the square root of 16? Well, what times itself is 16? There's 16. What times itself is 16? 4 times itself. 4 times 4 is 16. What times itself is 81? We look up here, 81. Sorry, that would actually not be the 81 that we're referencing because that's the power of 3 to the 4th. But if we have 9 to the power of 2, 9 times itself is 81. So 49, what times itself is 49? 7 times itself is 49. And then what times itself is 18? Well, 3 times itself is 9, 4 times itself is 16, 5 times itself is 25. So this is not going to be what we call a perfect square. This is going to be somewhere between 4 and 5. It's going to be a decimal, closer to 4, because 4 squared is 16 and 5 squared is 25. So we have these perfect squares that work out to whole numbers, but then we also have square roots. And we'll eventually be reducing, learning how to simplify a square root. But if you type into your calculator the square root of 18, in fact, maybe we'll do that in just a second here. If I open up the calculator, we'll see how close we are to the square root, how close we are to 4 or 5. So let's see, take a second to do this. Inverse square root. So these two buttons right here, here's your little square root button. Square root of 18, we see is 4.24 for rounding to the hundredths place. And if we square that, we should get back to 18. So there we go. So this right here squared is 18. So we'll eventually learn how to simplify that a little bit, but there's the decimal that goes along with the square root of 18. Okay, so now I want you to be thinking about this little symbol here. We're used to square roots, but what is this symbol? So the symbol here is basically saying what times itself 3 times is 27. So what number times itself 3 times is 27? I actually think we can look back at the chart here and say, okay, here's our 3 row, 2 to the 3rd, 3 to the 3rd, 4 to the 3rd, 5 to the 3rd. Notice that right here, 3 times itself 3 times is 27. So the answer to that is going to be 3, and that is something called a cube root. This means to find the cube root. So cube means to basically multiply by 3. The cube root is what times itself 3 times is that number. So let's fill in the blanks for what I just said then. That means to find the number that you cube to get 27. And again, cube means to raise to 3rd power. That's what cube means, to raise it to the 3rd power, just like square means to raise it to the 2nd power. And that means what number do you multiply by itself? And by itself again. So in other words, 3 times to get 27. So 3 times 3 times 3, 3 times itself 3 times is 27. So 3 is the cube root of 27. Okay, so I want you to think about these for just a